India's Chandrayaan-3, History, Present and Future. Introduction. The Chandrayaan-3 mission, part of India's lunar exploration program led by the Indian Space Research Organisation ISRO, represents a significant milestone in India's journey to explore the moon. Following the lessons learned from the previous mission, Chandrayaan-3 successfully achieved a soft landing on the moon on August 23, 2023, becoming the first mission to land near the lunar South Pole. This report delves into the historical context of the Chandrayaan missions, the current status of Chandrayaan-3 and future prospects, including the upcoming Chandrayaan-4 mission. Historical background. Chandrayaan-1 and Chandrayaan-2. Chandrayaan-1, launched in October 2008, marked India's first foray into lunar exploration. It successfully discovered water molecules on the moon's surface, significantly contributing to our understanding of lunar geology and the presence of water in the solar system. However, its successor Chandrayaan-2, launched on July 22, 2019, faced challenges. The mission comprised an orbiter, lander Vikram, and rover Pragyan. While the orbiter continues to operate successfully, the Vikram lander crash-landed during its descent due to a software error, failing to deploy the Pragyan rover. This failure prompted ISRO to reassess and refine their approach for future missions. Development of Chandrayaan-3. In light of the Chandrayaan-2 setback, ISRO initiated the development of Chandrayaan-3, focusing on ensuring a successful soft landing. The mission was tailored to include only a lander and rover, eliminating the orbiter, which was already operational from the previous mission. Key mission information. Launch date, July 14, 2023. Landing date, August 23, 2023. Landing site, Statio Shiv Shakti, near the lunar South Pole, 69.373 degrees south, 32.319 degrees east. Mission components: Vikram lander and Pragyan rover. Mission duration: approximately 14 Earth days, 1 lunar day. Mission progress: launch and lunar orbit insertion. Chandrayaan-3 was successfully launched aboard the LVM-3M4 rocket from the Satish Dhawan Space Center in Sriharikota. After a series of orbit-raising maneuvers, it entered lunar orbit on August 5, 2023. This phase was crucial for ensuring that the lander could safely detach and begin its descent. Successful landing. On August 23, 2023, the Vikram lander successfully executed a soft landing on the lunar surface, marking India as the fourth nation to achieve a soft landing on the moon and the first to land near the lunar South Pole. This achievement was hailed as a significant technological advancement for ISRO and the nation. Surface operations. Upon landing, the Pragyan rover deployed from the Vikram lander. It traveled 101.4 meters across the lunar surface, conducting experiments to analyze the soil composition. Notable discoveries included the detection of sulfur and other elements which are vital for understanding the moon's geological history. The mission's operational phase lasted for 12 days, after which the instruments were put into sleep mode due to the onset of lunar night, where temperatures can plummet to -120 degrees Celsius. Significance of the findings. The data collected by the Pragyan rover and Vikram lander contributes to understanding the moon's surface composition and the presence of water ice, which is crucial for future lunar exploration and potential human colonization. Future prospects: Chandrayaan-4. Following the successful completion of Chandrayaan-3, ISRO has begun planning Chandrayaan-4 with an anticipated launch in 2027. This mission aims to return lunar samples to Earth, demonstrating advanced capabilities in docking and sample collection. Objectives of Chandrayaan-4. 1. Safe and soft landing. Achieve a controlled landing on the lunar surface. 2. Sample collection. Collect and containerize lunar regolith and subsurface samples. 3. Lunar ascent and docking. Demonstrate the ability to ascend from the moon and dock in lunar orbit. 4. Return to Earth. successfully return lunar samples to Earth for scientific analysis. Technological innovations. Chandrayaan-4 is expected to incorporate advanced technologies including a multi-module design for efficient sample collection and return. The mission will involve 2 separate launches with the spacecraft modules assembled in Earth orbit before proceeding to the Moon. Conclusion. The Chandrayaan-3 mission signifies a pivotal moment in India's space exploration efforts, underscoring ISRO's resilience and ability to learn from past challenges. By achieving a successful lunar landing and conducting valuable scientific experiments, India has solidified its position as a key player in the global space arena. The upcoming Chandrayaan-4 mission holds the promise of further advancements in lunar exploration and sample return capabilities, paving the way for future human missions to the Moon and beyond. Counterintuitive information in the Chandrayaan-3 mission. 1. Success after a failure. It may seem intuitive that failure would lead to setbacks and delays, but in the case of Chandrayaan-2's failure, the subsequent success of Chandrayaan-3 was not just a matter of learning from mistakes but also a demonstration of ISRO's resilience and adaptability. The failure of Chandrayaan-2 was a critical learning experience that led to the successful design changes and operational strategies implemented in Chandrayaan-3, showcasing how setbacks can catalyze future successes rather than hinder them. 2. Cost-effectiveness in space exploration. There is a common perception that successful space missions require enormous budgets, akin to those of NASA or ESA. However, Chandrayaan-3 was accomplished at a fraction of the cost of similar missions from other countries, with a budget of approximately 615 Indian rupees crore, around $84 million. This emphasizes that effective engineering and management can lead to significant achievements in space exploration without excessive spending, challenging the narrative that high costs are synonymous with high-quality outputs. 3. Landing near the lunar South Pole. Many might assume that landing on the Moon, especially in the unexplored southern polar region, would be an incredibly risky and complex task likely to lead to failure. However, ISRO successfully landed Chandrayaan-3 at the lunar South Pole on its first attempt, becoming the first agency to do so, which contradicts the general assumption that such regions are too challenging for initial missions. This success highlights India's advanced capabilities in navigation and landing technologies. For public engagement and interest, the assumption might be that space missions are primarily of interest to scientists and engineers. However, Chandrayaan-3's landing was watched by over 8 million viewers live on YouTube, setting a record for the most concurrent viewers for a live-streamed event. This indicates a strong public interest and engagement in scientific endeavors, suggesting that space missions can transcend niche audiences and become significant national events. 5. Short mission duration but high impact. It is often thought that longer missions yield more data and discoveries. Chandrayaan-3's operational period on the lunar surface was only about 14 Earth days, yet it delivered substantial scientific findings, including the detection of sulfur and other elements. This challenges the assumption that duration is directly proportional to mission success and data richness. 6. Nuclear technology in spacecraft. The incorporation of radioisotope heating units (RHUs) in the propulsion module was not previously widely communicated, and it's counterintuitive to think that nuclear technology would be used in a spacecraft for lunar missions. Many would associate nuclear technology with military or energy sectors, not with peaceful explorations in space. This application underscores a broader potential for nuclear technology's role in future space explorations, particularly for instruments that need to operate in harsh environments. 7. Communication and collaboration. The perception that space agencies operate in isolation is common. However, Chandrayaan-3 exemplifies international collaboration, as seen with NASA's contribution of a laser retroreflector and support from ESA for tracking. This highlights a counterintuitive reality that cooperation among countries can enhance the success and capabilities of space missions rather than competition. 8. Public reactions to failure. the emotional response to the failure of Chandrayaan-3 was a mix of disappointment and support for ISRO, demonstrating a public understanding that failure is a part of the scientific endeavor. This is contrary to the notion that failure in high-stakes missions would lead to public outcry or loss of faith in scientific institutions. Instead, the public rallied behind ISRO, celebrating the learning process and resilience shown in subsequent missions. Conclusion: the Chandrayaan-3 mission encapsulates a series of counterintuitive insights that challenge conventional wisdom about failures, costs, mission durations, public interest, and the role of technology in space exploration. These aspects reflect a paradigm shift in how space missions are approached, executed, and perceived, showcasing India's growing capabilities and the broader implications for the future of space exploration. The Chandrayaan-3 mission represents a pivotal moment in India's space exploration narrative, marking not just technical achievements but also broader implications for India's position in the global space community. While the successful landing of the Vikram lander and deployment of the Pragyan rover have drawn significant attention, there are nuanced aspects of the mission that are often overlooked yet hold substantial significance for the future of lunar exploration and India's ambitions in this arena. 1. Learning from failure, the significance of Chandrayaan-2. One of the most critical yet understated aspects of Chandrayaan-3 is its foundation on the lessons learned from the Chandrayaan-2 mission, which experienced a landing failure in 2019. The iterative learning process that ISRO undertook is fundamental in engineering disciplines, particularly in aerospace, where risk mitigation is crucial. The adjustments made to the Vikram lander for Chandrayaan-3, such as enhanced software for altitude correction and improved structural integrity, demonstrate a robust response to previous setbacks. This learning curve is significant as it showcases India's resilience and commitment to advancement in space technology. The narrative surrounding failure is often shunned in public discourse, however, recognizing and embracing failure is essential for innovation. This shift in perspective can inspire other nations and organizations to adopt a similar approach, fostering a culture of continuous improvement. 2. Strategic importance of the lunar South Pole. Chandrayaan-3's landing site near the lunar South Pole holds strategic, scientific, and geopolitical significance. This region is believed to harbor water ice, which could potentially support future lunar missions and even sustain human presence on the Moon. The presence of water is vital as it can be transformed into hydrogen and oxygen for propulsion and life support, making the South Pole an attractive target for future manned missions. Many nations are developing plans for lunar exploration, and having a foothold in the South Pole region can provide India with a competitive edge in future international collaborations and partnerships. The strategic importance therefore lies not only in scientific research but also in positioning India as a key player in future lunar endeavors, which could include resource extraction and long-term habitation. 3. International collaboration and soft power. The Chandrayaan-3 mission exemplifies India's growing international presence in space exploration. The inclusion of a NASA-supplied laser retroreflector array on the Vikram lander highlights the collaborative spirit that is vital for advancing science and technology. Such partnerships enhance India's soft power by showcasing its capabilities and willingness to cooperate on global scientific challenges. Moreover, the successful execution of Chandrayaan-3 enhances India's reputation as a reliable partner in space exploration, which can lead to more collaborative projects in the future, not only with the United States but also with other spacefaring nations. This diplomatic aspect of space exploration is often overshadowed by technical achievements but is crucial for fostering peaceful international relations and scientific advancement. 4. Technological innovations and future missions. Chandrayaan-3 is not just about achieving a successful landing, it embodies a range of technological innovations that will inform future missions. The propulsion module's ability to transition back to Earth's orbit for continued scientific observations is a testament to ISRO's engineering prowess. This capability could be vital for future missions requiring flexible operational strategies such as sample return missions, which are being planned with Chandrayaan-4. The planned Chandrayaan-4 mission intended to return lunar samples to Earth reflects an ambitious vision for India's lunar program. The multi-module design, which necessitates docking in space, is a significant step forward in complexity and capability. This progression towards advanced mission profiles underscores the importance of Chandrayaan-3 as a stepping stone towards more sophisticated lunar exploration objectives. 5. Public engagement and national pride. The public engagement surrounding the Chandrayaan-3 mission has been remarkable, with millions tuning in to watch the landing live. This level of public interest is significant as it showcases the power of space exploration to ignite national pride and inspire future generations. The emotional connection that citizens feel towards such missions can drive educational initiatives and encourage youth to pursue careers in STEM fields. Celebrating achievements like the successful landing is National Space Day not only instills a sense of pride but also promotes awareness of the importance of science and technology in national development. This cultural aspect of space exploration is often overlooked but plays a crucial role in shaping a nation's identity and aspirations in the global arena. Conclusion. While the immediate technical achievements of Chandrayaan-3 are noteworthy, the broader implications for India's position in global space exploration, the lessons learned from past failures, and the potential for future collaborations are equally significant. Acknowledging these often overlooked aspects can enrich the narrative of India's space journey, fostering a deeper understanding of the complexities involved in space missions and the potential for international cooperation in the pursuit of knowledge. As India prepares for future missions, these foundational elements will not only guide technical advancements but also shape its role as a leader in space exploration. 1. Historical significance and lessons learned from Chandrayaan-2. The Chandrayaan-3 mission emerged as a direct response to the setbacks experienced during the Chandrayaan-2 mission, where the Vikram lander failed to achieve a soft landing. The historical context reveals that ISRO, Indian Space Research Organization, used the lessons learned from the Chandrayaan-2 failure to enhance the design and operational protocols of Chandrayaan-3. This highlights the importance of resilience and adaptability in space exploration, emphasizing that failures can serve as critical learning opportunities that inform future successes. 2. Technological advancements and achievements. Chandrayaan-3 marked significant technological advancements within ISRO, including improved landing technologies and enhanced rover capabilities. The mission successfully executed a soft landing near the lunar South Pole, making India the first country to achieve this milestone on its first attempt. Key technological innovations included the Vikram lander's new propulsion system, which allowed for better altitude and descent control, and the Pragyan rover's scientific instruments that confirmed the presence of sulfur on the lunar surface. These advancements not only underscore India's growing capabilities in space exploration but also contribute to global scientific knowledge about the Moon. 3. International collaboration and recognition. Chandrayaan-3's success illustrated the importance of international collaboration in space exploration. Partnerships with organizations like NASA and ESA for telemetry support and shared scientific objectives have fostered a cooperative spirit in the global space community. The mission's achievements have garnered international recognition, with congratulations from various global leaders and space agencies, further solidifying India's position as a key player in space exploration. This aspect highlights how collaborative efforts can enhance the effectiveness of space missions and contribute to shared scientific goals. 4. Future prospects with Chandrayaan-4. Looking ahead, the planned Chandrayaan-4 mission aims to build on the successes of Chandrayaan-3 by focusing on lunar sample return capabilities. This mission is set to demonstrate complex operations such as docking and sample collection, marking a significant progression in India's lunar exploration agenda. The anticipation surrounding Chandrayaan-4 illustrates a forward-looking approach to space exploration, where each mission not only serves immediate scientific goals but also lays the groundwork for future endeavors, potentially including crewed lunar missions. The strategic vision for lunar exploration reflects ISRO's commitment to expanding its capabilities and contributing to humanity's understanding of the Moon and beyond. Here are 3 famous historical cases that are similar to India's Chandrayaan missions, focusing on significant achievements in space exploration and lunar missions. 1. Apollo 11 Mission 1969. The Apollo 11 mission marked a pivotal moment in human history as it was the first manned mission to land on the Moon. Launched by NASA on July 16, 1969, the mission aimed to fulfill President John F. Kennedy's goal of landing a man on the Moon and returning him safely to Earth before the end of the decade. The spacecraft consisted of 3 components: the Command Module Columbia, the Service Module, and the Lunar Module Eagle. On July 20, 1969, astronauts Neil Armstrong and Edwin Buzz Aldrin descended to the lunar surface while Michael Collins orbited above. Armstrong became the first human to step onto the Moon, famously stating, "That's one small step for a man, one giant leap for mankind." The mission successfully returned to Earth on July 24, 1969, achieving its objectives and marking a significant achievement in space exploration. 2. Luna 16 1970. The Soviet Union's Luna 16 mission was a milestone in lunar exploration, becoming the first robotic mission to return soil samples from the Moon. Launched on September 12, 1970, Luna 16 aimed to land on the Moon's surface, collect samples, and return them to Earth. The spacecraft successfully landed on the Moon on September 20 in the Sea of Islands. It used a drill to collect a sample of lunar soil weighing approximately 101 grams. The mission utilized a unique return capsule that re-entered Earth's atmosphere and landed in the Soviet Union on September 24, 1970. Luna 16's successful sample return contributed significantly to lunar science and demonstrated the capabilities of robotic space missions. 3. Chang'e-4 Mission 2019. The Chang'e-4 mission, launched by the China National Space Administration (CNSA) on December 7, 2018, achieved the historic feat of being the first spacecraft to land on the far side of the Moon. The mission's primary goal was to explore the lunar surface and conduct scientific experiments, particularly in the Aitken Basin, a region of scientific interest due to its ancient geological features. Chang'e-4 successfully landed on January 3, 2019 and deployed the Yutu-2 rover, which has since traveled several hundred meters across the lunar surface conducting various scientific analyses. The mission has provided valuable data on the Moon's geology and environment, significantly advancing our understanding of lunar science and the history of the solar system. These 3 historical cases highlight the achievements and challenges faced in lunar exploration, showcasing the advancements in technology and international competition in space exploration. Much like India's Chandrayaan missions. Future outlook for India's Chandrayaan program. The Chandrayaan missions represent a significant leap for India's space exploration efforts and showcase the Indian Space Research Organization's ISRO commitment to advancing lunar exploration. Following the successful landing of Chandrayaan-3 in August 2023, which marked India as the first nation to reach the Moon's south pole, the future of India's lunar missions looks promising. Upcoming missions: Chandrayaan-4. 1. Mission objectives. Sample return. The Chandrayaan-4 mission is planned to be a lunar sample return mission aimed at collecting up to 3 kilograms of lunar regolith from the same vicinity as Chandrayaan-3's landing site Station Shiv-Shakti. This will enhance our understanding of the Moon's geological history and the presence of resources such as water ice. Technological advancements. The mission will demonstrate advanced capabilities including docking and undocking between modules in lunar orbit, which is essential for future deep space missions. 2. Launch timeline. Expected launch, scheduled for 2027. Chandrayaan-4 will be a complex operation involving multiple launches. The first launch will carry the lander and ascent vehicle, while the second will deliver the transfer and re-entry modules. 3. Technological innovations. The mission will incorporate high-end technologies including a novel design for the spacecraft that can support multiple modules. This will also involve the development of a robust propulsion system capable of executing precise maneuvers necessary for a successful lunar landing and sample collection. 4. Collaboration and support. ISRO is expected to collaborate with international space agencies and private sector partners to leverage expertise and resources, enhancing the mission's scope and capabilities. Long-term goals. 1. Sustainable lunar presence. The success of Chandrayaan-3 and the planned Chandrayaan-4 mission will lay the groundwork for a sustainable human presence on the Moon. Future missions may focus on establishing lunar bases or habitats utilizing local resources and conducting longer-duration scientific research. 2. Involvement in global lunar exploration. As global interest in lunar exploration grows, India is poised to play a significant role in international collaborations, including potential partnerships with NASA and other space agencies for future lunar missions and research. 3. Broader space exploration initiatives. Chandrayaan missions are part of ISRO's broader vision, which includes ambitious plans for Mars and Venus exploration, as well as the Indian human spaceflight program Pragyan. These initiatives will further solidify India's status as a major player in global space exploration. 4. The technological advancements in spacecraft design. The lessons learned from Chandrayaan-3 regarding lander design and operational effectiveness will influence future spacecraft designs, leading to more reliable and capable missions. Conclusion. The Chandrayaan program, particularly with the anticipated success of Chandrayaan-4, positions India at the forefront of lunar exploration. The commitment to advancing technology, fostering international collaboration, and pursuing ambitious goals underscores the potential for India to become a leader in space exploration. As it builds on the successes of its predecessors, ISRO is not just exploring the Moon, it is charting a bold path for future generations in the field of space science and exploration.